Hello everyone. Can't help myself, got to do it. I know, lots of chemistry in it. Well, periodic table. And also I haven't even got the pen that this is about. It's arriving soon, but not yet. Too bad. It's just too exciting. This right here is a really nice pen by Asfine. Look at that rainbow effect. And then at the end, we've got a titanium nib. It's an Ultraflex nib by Canwrite. That's fantastic. And look, writes like that, and I'm a lefty, as it says. So that's pretty sweet. But this titanium rainbow effect, is that the best we can do? Well, what metal could we use to make an even cooler fountain pen out of? Glad you asked. All right, so this is my table of elements. Each cube is a pure sample of that particular element. So you've got the gases, that's hydrogen gas in a little glass cube, all the noble gases here. You've got bromine liquid, you've got some chlorine gas here, you've got a bit of sulfur. You have a really weird alloy of gold that makes it pink. You know, all this stuff. And you can see these are all metals, right? Most of them. They're looking really shiny and lovely. Oh, what's that one doing there? Which one is it? It's gadolinium. Yeah, gadolinium. That's one of the mid-rare earths. So yeah, that's the rare earths here that everyone keeps talking about these days. And that click is coming from my Geiger counter, which is telling me there's not really much radiation around here. That is despite the uranium cube that I have here, because it's behind some really thick glass there. Not glass, yeah, I suppose it is. So anything from 0.5 microsieverts per hour is about the same as background. So this has gone up a little bit, but you know, it's about the same as living nearer to the poles than here. It's really very, very little. You'd have to go about 1,000 times to make it anything to worry about. And yeah, so that's a cube of pure depleted uranium. That's why it's not so bad, because the uranium... Anyway, we're talking about pens. What the hell? All right, which one? What's the best metal for pens? Well, we've just looked at the titanium, which is over here. And anyone who knows the periodic table, it's if you go down in one column, they end up being quite similar in behavior. And that's true here. So this guy here, zirconium, is it's a metal that's got a similar properties to that of titanium. So here's a chunk of it. This is some pure zirconium. It's quite light relative to other metals. The beauty of this stuff is that it absolutely does not corrode. So you can have... you know, 200 or 300 degrees Celsius in hydrochloric acid. Oh, no, that's not true. Let's say sulfuric acid. Hydrochloric's a bit different. But anyway, yeah. Definitely 300 degrees C. Let's not talk about that too much. Okay. Zirconium, really, really nice. Has very similar effect to that of the titanium, which, as you can see, is directly below it. Yes, a titanium and zirconium. Yeah. What can it do that makes it so nice for pens? Well, this is what my next pen's going to look like. Isn't that nice? So that's a rainbow Damascus effect that you get when you heat treat after having hammered and polished, hammered and folded and folded and hammered and folded and hammered. And then you heat treat it and you get this beautiful effect. This is my new PenBBS 559 that's about to get on its way to come to my house, and it's going to be amazing. It has a number 8 pressed nib, 14 karat gold, some of the smoothest on offer, with a ebonite feed and a lot of love.